So this time let's look a little bit into the print function, previously the print statement, and what we can do with it. Maybe format some strings, write it out into a file and read it back in, which is obviously quite useful. For this we start a new notebook in our Jupyter Lab server running. So start a new Python 3 notebook. Let's call it, right click on the title, let's call it print and save maybe. So first of all, escape and then go in here, escape and M, enter, and this is, let's give it a title, the print function, right? And so previously meaning before Python 2.9 something, or before Python 3 basically, you had a print statement. Since then, and since Python 2 is no longer supported, everything Python 3 is print functions, which means you can print, you have a function, a built-in function print, and whatever you put in the brackets will be printed on screen. And this can be a string, or if it's not a string, this object needs to have some sort of representation if you want to print it. This goes a little bit too far, but for now, let's say you want to print just the integer 10. Python automatically knows how to convert this. But if you want to specify how to convert this, we're going into formatting. This comes later. But let's say this is a value of something. We can just attach a variable a, and we have to declare this variable first and fill it with something. If we do this, then a equals 10. We fill the variable a with the number 10, integer 10, and then what we do is we print the string, this is the value of, and append whatever Python thinks the string representation of 10 or of a, in this case 10, might be, and it's just 10. Obviously, if we have something, let's import the math module, and a, let's call it pi, maybe, pi is equal math.pi, and we just print pi, we have no way of saying, for example, what the precision of this thing might be. For this we need string formatting, and we'll get back to that. This is especially important if you want to save data, and you want to save data to a certain precision. You maybe don't care about all these digits, and you want to only specify, you want to have the first four digits, for example. We can easily do this in a couple of different ways. So let's first go through the old way. The old way would be you have a string and then the % sign and then some value, some variable, pi, right? And then in the string you would specify how you want to format this. With the % sign again, so % and then let's say we want to have 4 digits, right? The precision of 4 digits. This would be 0.4, and then because it's a float, we add the f. Now we have 4 digits and it rounded to the last digit. Okay, this is the old way. As I say, the newer way with this % notation, it's a little bit unflexible, because if you want to have multiple variables, you always have to have the % here, and you have to keep track of which variable. For example, if you want to have different values, 3, 4, 5 in here, you would need to specify each time, let's call it 02d as an integer, and %02d and %05d, right? Now we have 4 values in this bracket here, and we have 4 % signs in here. So this would spit us out the 3.1416 in the first case, then a space, and then a trailing 0 for a 2-digit integer. Same here. So that would mean 3 with 2 trailing digits, which would mean or two in total. That would mean 03 space 03 04, and then space, and then 0005 in the end. Let's do this. So this is the first one we had already, 03, 04, but now we have to keep track of the order of these things and where we want to put them. It's a quite inflexible way of doing things. So now we have the format, a string formatting option. So we have again a string, but we format. We have the format option, which is any string has this format function now attached to it. And now we introduce curly brackets in here, so we can say something like a, b, curly brackets b, curly brackets c. Let's call the first one pi, b and c, and we can format pi, and then b equals 3, and c equals 4, for example, right? Pi equals pi, sorry, we have to import this in here. So now we have the same thing again, but now they are named in the string, the representation is named again, so we can include them in here. Which gives us more flexibility. We could, for example, turn this around and say, okay, we want b first and then pi, but in the end, in the format, we don't care about the order here, and we do this, and we get the desired output. If we now want to add a precision, similar as we did here, we can do the same thing, but with the colon. So pi, we want to have a precision of 4 digits, so .4f. And if we do this, we get the same thing here. Maybe we want to have the b with a trailing 0, with 2 trailing zeros, like do this, right? And so on. So this gives us more flexibility because we have named variables internally in the string. There's a third way of doing this. It's recently introduced into Python. It's called f-strings, formatting strings basically. So instead of just having the string here, we write an f and then the string. And the benefit is we can declare variables beforehand. A is 1, b is, let's say, 2, and we have pi already. Let's do it again, math.py. And now we can, because we know already, or Python knows already, the a, b, and pi variables, because they are already declared, we can reference them directly. Right? So in this f-string case, we can here just give out a, and pi, the order also doesn't matter, and b. Right? Same as before, this notation here stays the same. So if we want to, for example, add 2 trailing zeros to b, right, we would do b colon 03d, and this would give us a 002 here, and we could also limit maybe pi to a precision of 3 decimals, and the a we want to limit to maybe also 3, right? So .3f here in this case. Okay, so now we have a nice representation. We might also be interested in doing something where we have a leading, sometimes we have negative values, so for example if a is negative, right, in this case, this representation is not so nice. If we add a space here, in this case, it will print a space if the number is positive and a minus if the number is negative. So in this case, this should, if I evaluate this, shift enter, it stays the same, but if I turn a positive, we see now we have a trailing space. This is nice to keep things nicely organized in a text file, for example. Okay, there's a lot more information on how to do this string formatting, and there's it's a broad topic. So let me quickly show you where you can look this up. I would go to, obviously, if you type just into your favorite search engine, Python string formatting, you will get a bunch of things that you can look at, and you see already I clicked here at some point. But the question is how, and this is often in Python the case, there's so much information online, which one do you choose, right? I would always start with the Python documentation and see how far that gets you. So because it's quite good. So if you go to docs.python.org, you don't need the 3, you automatically get forwarded to the current version. You can also specify the version you are working with, but typically it's also in the documentation, it's specified if something doesn't work for the version you're working with. But for the most generic stuff, there shouldn't be any problems. So let's click here on the library reference. Keep this under your pillow. Nice recommendation. So let's click here, the Python standard library, because we're dealing with, in our case here, with the print and save notebook. There's nothing fancy. It's all standard variables, standard standard modules. So we're basically operating in the standard library. So, and here we have under text processing services, for example, we have a bunch of stuff to read, how to use regular expressions, for example. But for string, common string operations, this is what we're looking at, because we want to turn something into a string, right? We want to turn some numbers into a string representation of some kind. So common string operations, and then you can see what kind of constants are available for any string. And then custom string formatting, there's a whole section about it. You can read up on this, and this is format explained and so on. And there typically at the end of the documentation, there's always some examples, right? So format examples. And here you can see this format option that we have here. F-strings is another topic, but also what's quite interesting in here is the documentation of these abbreviations I used. For example, the .2f we used previously, or the .3f. So this f here is referred to here. So this is an overview over the different representation types of data, of numbers in string. F, for example, for fixed point notation for a given precision p. This is in our case the .4 is the 4 is the precision. Formats the number as a decimal number with exactly p digits following the decimal point. With no precision given, uses a precision of 6 digits. So there's a lot of information here that you can choose, and you can specify what you need and get the information to suit your use case. Okay, so that was a bit dry, so let's maybe make an example. A common example is you have some data and you want to save it as a text file, for example. Right? So escape M here, let's create some data, some example data. How do we do this? We already had the NumPy module, let's use it. So import NumPy as NP. The NumPy module provides, for example, the linspace. We had this already, I'm keeping it simple. So from 0 to 2, from 0 to 200 in 100 steps, right? And y is then equal to some function, x squared, right? If we, just for shits and giggles, let's plot this, plt.plot x comma y. This doesn't work because plt, the plot command, is not available yet. We have to import the matplotlib, matplotlib.pyplot library, for example, as plt. And now we see that from 0 to 200 we have our linearly spaced values here, and then the y-axis gives us the nice parabola. So we have now, if we look at the length of x, it's an array of a length 100, so x and y, y same thing, have each 100 entries. So let's assume we want to save this data x and y to some text file. Right? The easiest way to do this would be to use an inbuilt function of NumPy, np.saveText, for example. We're not going to do this. Let's do it the hard way. Let's program this ourselves. It's not that hard, but we can use what we've learned so far about for loops, for example, and string formatting to get this in a nice format, to get this out into a nice format. How would we start? So first, we have to decide how our representation in the file should actually be. So let's quickly look at X. Okay, it's a lot of numbers, and they have three, as we specified, 3 digits in the front and a couple in the back. With Y, it's a bit more complicated here because the exponential notation is used. This 2.75 thousand, and this goes up to 36 10,000. Right? So 40,000. Now we have a rough idea how our numbers look. Let's see if we can find, let's choose 1, right? Let's say x1 and y1. By the way, we can specify or declare or assign 2 variables at the same time by giving just it this way, doing it this way. So x of 0 and y of 0. This means x0 is assigned to x1 and y0 is assigned to y1. If we do this, we now have 2 values, x1 and y1, which is both 0 because it both starts at 0. Right? Maybe let's make it more interesting. Let's do 5 just for an example, because now we have numbers that we can actually nicely format, or we have to nicely format. The question is now, how do we want to format this to put it into our string or into our file? Let's do this by using the f-strings, for example. So we have an f-string, and we have now our x1 here, right? And we need curly brackets in order for the f-string to recognize that it's a variable name. And just make a space, basically, maybe, in the beginning, and then y1. What happens if we do this? Okay, this is not a nice representation of the string. If you write this for all the 100 or 200 data points in our string, in our text file, it looks rather messy. Maybe we don't need all these numbers, all this precision. Let's say we want to limit this to 4 digits. So same as before, the colon, and then 0.4f because it's a float, and the same thing here. This would be 0.4f. Colon dot 4f. Okay, this looks better, but now we run into a problem. If we, instead of doing 5, so we have here 10 and 100. If we go to 50 here and do the same thing again, we see that now we have here 5 digits in the front. It's not a problem, but it might not look so nice. So let's do it in a loop to see what I mean. So introducing a loop for I in range of, let's do the first 20 maybe. Let's try this, and we just print out this string that we created here. But instead of x1 and y1, we're now using the ith entry, right? For the 0th entry, the first entry, the second entry, and so on, every time it executes the loop. Same here, y of I. And if we do this, we expect to get 20 values, 20 lines out, and in each line, this string representation as we specified it here. Yes? Let's do this. Okay, and this is what I mean, because the numbers increase in the y value and the x value as well. We get this shift here, so the lines are not long, don't have the same length every time. If we want to fix this, and we know the maximum number is 40,000, so this is 5 digits long, we can actually do a for the y, let's start with the y here, a left bound. So it's a smaller, and we want to have 5 precision here. And so this was wrong. The smaller sign as you can read up on the the string library, means that it's aligned to the left, but what we want is aligned to the right, so we need the greater symbol. So greater, and then we need to calculate not how many spaces should be in total occupied by this number. So we have 40,000 as our highest number in here, so that's 245, right? Plus the 4 here, so that's 9 plus the dot, it's 10. So let's go with 10.4f. So now we see this has been moved properly to the right. We have beginning spaces, prefix spaces where we want them, but we still have this issue here with from the 8 to the 10. There should be a space here, so we do the same here. We right align the text here, and in this case we only go as high as 200. So with 200 we have 3 plus 4, 7 plus the dot is 8, 8.4f. Right? So if we do this, then everything is properly aligned, and we don't have, at maximum, we only we have this we get to that error, but in maximum we have one space in between, and then we have nicely formatted all in a nice block here. So in this case here, for example, two beginning spaces, and here 5 beginning spaces. Okay, I increased the number that we can see the 40,000 in the end here, so not the range of 20, but I increased the number of points here from 20 to the 100 that we have as a maximum length, so that we can see all the way until the end here. Okay. So this is, we're almost done. Now we only need some way of writing this. We printed out everything nicely. Now we need some way of putting this into a file, right? Remember we wanted to put this in a file. There is a way of doing this, and if we go here to our browser, we can create a new folder. Maybe let's call it data. If we open up the data folder, there's nothing in there yet, but basically we can open up an empty or a new file. Let's call it F for file with the open command. So we open up some space on the hard drive, and because we're currently in the home folder, we need to go to the data. We need to go to the data folder that we just created in the home folder. And we're going to call the file test file .dat. And we want to open this with the argument write. We want to write something, not read something from this file. We want to write something into the file. And to be sure, we want to also set the encoding to Unicode, so UTF-8. And this also needs to be a string. So this now opens a file or a point on the drive, on the hard drive, where we can save something. And now, instead of this print function here, what we do is we want to write this into the file f.write. So we created this object, which is an open file object, and this open file has now an option or a function called write. So we can write something into this file. This would write, because this write doesn't add a new line character in the end. So here in the end we have to add a new line character, otherwise for each step it will just, let's omit it for now and see what's happening. In the end, we'll get back to that. In the end, we want to close this file that it can be read afterwards again, right? So if we execute this, what will happen is now Python opens this file, testfile.dat, in write mode, and with the encoding UTF-8. Then for each I in range of 100, so for 100 steps, right? In each step, write one entry, the ith entry of x and y, with this format, with these formats, into this file. Then close the file. Let's execute it. We don't get any output and no error, but we see a test file appeared here. If we open this, we see it's not really nicely formatted, and we see here with the line numbering it's only one line. Because the save or this write command here, this opens up the file and writes everything exactly as it is right after whatever was in the file before. So that means we have to add a new line character here. So \n adds a new line character. There's some differences between operating systems, Unix and Linux, but as long as you're staying into Python or the POSIX operating systems basically. In Windows it would be character return and line feed. In Linux or Unix systems, also Mac, it's just the new line character \n. If we execute this again, this test file here, let's close it, is overwritten, and now we have a new line character after each step, and we have a nice file with 100 entries, and the data is nicely displayed in this file. Okay, so it is quite, if your code gets more complicated, you sometimes forget to close the file. So there is a more elegant way of doing this, and this is with the with statement. So let's quickly introduce this. The with statement is with some object, and you can name it, do something. And as soon as you leave the block, the indentation, right, with some object, do something, or you can call it as ob, whatever, object name, do something. And then afterwards, if you close the indentation here, if you close this block, it will close it automatically. The some object will not exist then, or will be closed afterwards automatically. So let's implement this in for our write and open and write function for the file. So with open this, and we call it f, right? And then now we have to put the whole for loop in this new block, and we have to increment this, but we don't need the f.close anymore. And because this file automatically is closed after the open statement has finished, which is here at the end of the block. So let's do this, and we close it again, open it, and obviously it's the same as before. 4 digits, let we see that something changed. Let's change it to 5 digits here, just run it again, open up test file, and you see now it's 5 digits here, so something did actually change. Okay, so now we have a way of writing something out into files. We want to maybe read it back in again, right? We want to read back in the data that we just saved. So let's do this. Also again with the with statement. So with, and I can copy paste this basically. So with open the same file, but not as a write file, but as a read in read mode as f, and then let's call it L equals f.readLines. So now we have L is then a list, that's why I called it L, of all the lines that are read then from the text file. So if I look at L now, we see each element of the list is one line, but it's still in this as one string, right? So for example, if we look at the first element, L of 0, it's now a string, exactly as it was as the first entry in this text file. Right? Plus the new line character that is not displayed here. So this is here. So if we want to get rid of the trailing or of the prefix space and the \n here, we can do what's called a string strip. Right? If we do this, all these special characters are stripped and only the number is kept. Right? Now we can do we want to split this somehow into 2 parts, right? So let's do a split. And now we see we get a list back of 2 entries, the first one and the second one. They're still strings, so you see the quotation marks. So we would have to get them to be recognized as something else, as strings. Python does not yet know what we want to do with this, so it's still a string because the string was read from the file. Okay, so let's call this something A, right? And A of 0, A of 0 is now the first entry, and we know it's a float. So we have the float of A0. We want to turn this string into a float, and we want to do the same for the second one, so A of 1. Right? If we do this, we get now a tuple, or this tuple is because we printed it like this. We get a nice float representation of the first and second entry. Now all we have to do is do this for all of the lines in this text file, or in these lines that are in this list L now. A for loop might be in order, so for, let's call it LL, in our list L, right, do something here, and in this case, in the first run, right, the first element of L is then LL, and in the second run, the second element of L is then LL. So instead of addressing this here, we can just use LL, and that should work, right? Let's quickly check if we get something reasonable out. Let's print this out on the screen, and we get nice float representation out. So everything seems to work. But we don't want to write this out as a print function now. We want to put it maybe in like the red or X red and Y red variables, right? And let's make them lists. So two empty lists, X red and Y red. And now we want to append this first one. So X red dot append this first value here to the X red, and to the Y red we want to append the second float. If we do this, no errors, okay. So if we look now at X red, we now get a nice list of X's and of Y's. We can also, now just for reference, and we can plot this again. So first we had the original X's, right, were X and Y, right? This was this graph, so we have the plot X, comma Y. Let's copy this and paste it in here. And now we want to plot also the X red and the Y red, and maybe plot them with dot markers. So obviously these are on top of each other now, so let's quickly zoom in. Plot.xlim, just look between 75 and 100, 75, 100, and we see they are nicely on top of each other. Okay, so we now have a nice representation of these values X and Y that we saved in this text file in a certain format, read them back in, and we have them similar as before as lists available for our data analysis. Okay, there is a different way of dealing with this, saving data, not in a text file format. Right? Now here you have to make a decision, okay, at what precision do I want to save my data as? Let me quickly introduce one more way of doing this. It's not directly connected to the string, but it's more broadly applicable, and that's called pickle. So just pickle because we pickle something, and this is not defined in the standard library, but we can import the pickle module. And if we do something like pickle.dump, we dump some data into this pickle jar. That's the idea, basically. So if I do shift in this brackets, do shift tab, we see how this works. So we have some object that we want to pickle, so save on file, pickle in a jar, and some file object here. And the rest is optional. We see there are some default values set. Okay, so let's do this. We have some, as we say here, some object and some file. So, for example, we had our object X, which was a list, right? And We can also give him both x and y at the same time. For example, we can make a list of x and y. So a list of two elements. The first element is x, the second element is y. And now we have the file object f, which we have to open again. It doesn't exist yet, and we do this with the with statement. With open, let's also save it in data. Let's call it pickle file dot pkl, right? As f, and now we pickle dump the list x and y into this file which we just opened, pickle f. Right. Okay, so let's do this. Okay, so there is an error, a file not found error. We have to, what I forgot, we have to open this not as just as a file, because if we look here, shift into the bracket, shift tab, we have to specify the mode. The standard mode is read. We can't read it because it doesn't exist yet. But we also don't want to read it, we want to write it. So write, and I'm adding a binary because I don't want to have a text file, I want to have a binary file in the end. So this worked, right? So now in data pickle, this popped up a second ago here, this pickle file, I can open this, but yeah, it's a problem. It's not a text file. This editor doesn't know how to open this. It's a binary file. So, but we have to trust somehow Python that it pickled this in there correctly. If you want to read this file in, we can do the same thing, but instead of reading it, right? Writing it, we're reading it. We're reading the binary, this pickle file, and instead of pickle dump, we're gonna use pickle load. And if we check shift tab here, we have just as one parameter in this file, in this function load is the file. So it's just the file as a parameter. And here, let's call it our capital L is our list that we get out. Right? Let's do this, and if we look at L, it's a list of two arrays, one array and the second array. Similar as before, this goes until 40,000, so the second one is our y, because we saved it as the second one in this file, right? So let's call it x pickled is L of 0. It's the 0th entry of this reread pickle file, and y pickled is then the L of 1 element. And now we can do the same thing as here. Copy paste it in here, and instead of the red, we now plot the pickled, just to see that we actually do the same thing and we get the same thing out. So these are there's more options, and we go over them later. How to save your data, but a pickle, saving it to a text file has its disadvantages. I mean, advantage is you can read it; it's human readable. The benefit, the downside is it's quite large, and you have to specify the format. If you pickle it, the format is implicitly basically saved. It's basically a memory footprint. Whatever is in the memory at that point behind this variable x and y is then pickled into some file in binary format. Right. So let's quickly add a new launcher here and go into a terminal. Let's go into the data folder, and we see these two files here. So these two are created, and I see, I mean, it's a quite small file anyway, but I see that the text file is 2.1 kilobytes and the pickle file is just 1.8, even though it contains the same data, however, or even more data. I mean, the xpickled pickled, as you can see, the first entry, let's go to the 10th entry, has a lot more data stored in it than, for example, the x red of 10, which is just the rounded values. So we have a lot more data in it, but it's smaller as a size because it's binary data, packed as binary data. Something to consider when you save your data. However, one downfall is it might be dependent on your Python version, that if you, for example, load some specific NumPy array, you pickle a specific NumPy array and you want to unpickle it or read it back into memory for a newer version of NumPy, that might not work. Right? So there is some downsides to this, where this text file obviously is agnostic to whatever version you're using. Okay, so as an example or as an exercise for home, try to do this on your own. Find some function, play around with some data, create some dummy example data, save it as a text file in some specific format that you specify yourself, and read it back in. See you soon.